good evening, everyone. Here I come again. I'm Joji Palahang. So basically, today we will make a video, uh, and I'll try to explain to you between the name equivalence and name the difference between name equivalence and structural equivalence. So for today's demo, I'll be making simple Java to differentiate between name and structural equivalence. So here is our guide. We need to write a program on our own choice. So for my case, I'll be making a Java program, and then I will discuss the difference between name equivalence from structural equivalence. So before we start, let's understand first what is the difference between name equivalence and structure equivalence, so that we can showcase how it is done in Java. So name equivalence dictates that two data types are considered equivalent in programming if they are sharing the same type and same type name or declaration. So for structural equivalence is determines that compatibility based on the internal structure. It could be the fields, types, or order, rather than explicit type names. So how do we do this in Java? So let's assume you have a classes. So a class can have multiple instances of a class. If we compare these classes together, let's say here I have a class, public class equivalence demo. So if we do it, I'll say class horse. Horse has a number of feet, or let's say name. Let's say name. Okay. Then another one will have I don't want this to be public. Okay. Gemini, let me type. Okay. Class chicken. So here we have also property of a chicken. Let's assume chicken can have properties of feet, color, those things. So just to have like a simple differences. So when you say name equivalence, in it means they are totally same type. So in this example, let's say I can have an instantiation of horse. Let's say horse, jumper horse equals to new horse. So I will have another horse, runner horse. Okay, new horse. And then let's say I have another. Let's say I have two horse and two chicken. Two horse and two chicken. So I'll say chicken, red chicken. So let's say red chicken, meat chicken. Let's say meat chicken. Let's assume this is for my meat production chicken. And then I'll have a chicken object, another instance of chicken. Let's say this is my egg laying chicken. Okay. So now the type equivalence, basically it will check if they are on the same type. So if I say print out print ln. So let's say if I compare jumper valid, let's say I will say valid name equivalence. Okay, here I have a jumper and a horse, a jumper and runner, and then the invalid one will be, let's say, valid name equivalence chicken and egg, meat chicken and egg chicken. Okay, so the question is this valid? Yes, because jumper is a horse object, an instance or an object of a horse, and runner also is an instance of horse. But okay, same thing for meat chicken and egg chicken. So if you run this program, this is not equal because we have different instantiation. Let's say we have different, they are in different object, they are in different reference. But if you compare between chicken and egg, a chicken and a horse, invalid because okay, this is our, let's say I will compare jumper, which is an instance of horse, and egg chicken is um, instance of chicken. So if you can see here right now, this is incompatible type because egg chicken is an instance of chicken and jumper is an instance of horse. So that's one of the example about name equivalence. Okay, so you can compare two objects if they are on the same class or the same object, and it will throw you an invalid compatible issue. So if they are on not the same object or class. So how do we apply structural? There are multiple ways to apply structural, but in this case, I can what I can do, I can say I can create an interface. So the goal of structural equivalence basically is checking the fields or the, the the property of an object. So what I can do, I can create an interface. I will not make this as a public interface. I will say animal. Yeah, thank you. Then an animal can have a property of a name, let's say, and it has a okay interface should be let's say animal can run, okay, or can jump, or can fly, okay. So now, since I have an interface, I can now make an animals class implementation. I could say let's use this example. I can do implements animal, and here we need to apply the run, and then another one jump and fly. Okay, and same goes for chicken. Implements animal, which have let's say jump. To simplify the process, I'll just copy paste. Okay, I'll format the document so it's much better now. So now, if I can compare, let's say, I'll say this one can run, this one can run. I'll return true. Return true. A horse can run. Wait, let me change implementation. Boolean. Same goes for. Okay, this is Boolean. This is Boolean. This is Boolean. So is can a horse can jump? Of course. true. Is does horse can fly? Of course not. And then for chicken, can chicken can run? Of course. Return true. And then for jump, and then for fly, of course, chicken can fly, but not same as bird. So now, as an example of structural, I can say. So now we have an instantiation of the class. So I'll comment it out for now. What can I do is I can create animal, chicken, and this will become new chicken, and a horse, chicken. Now if you compare now with the structural, what we can do is we can say chicken that chicken can fly, or horse can fly. So you see now in the implementation, I'm saying I want an instance of animal, which is an interface. Now I want another horse with the interface of animal. But basically, if you can see here, the difference is this chicken is an instance of the chicken class, and the horse an instance of horse class. But what I'm saying is I want an instance of animal out from class chicken and out from class horse. So earlier, if you compare chicken and horse without the implementation of interface, in the compilation error, it fails because they are not on the same class type. So you cannot. Here, you can do now, even though they are not on the same class, but with the help of the interface, I can now compare them accordingly. Okay, so that's the difference between name and structural equivalence. So structural, it will check the details or the fields or values of a class, but name, it is basically checking the the instance or the type of the instance. If it's in different class, of course you cannot compare it with different class. It will throw you some exception. Same thing for wrap data type. So for example, integer, double, if you see the primitive data types, they start with lowercase d, double, okay, but in the wrap classes, it will start by double, means it's an instance of a double, but it's a wrap under a class. Okay, that's all. Thank you so much.